So, good morning, everyone. I welcome you all in this live session where I'm going to discuss some of the question of mathematical physics that has been asked in NET-JRF Physical Sciences July 2025 exam. So, let's start. And you will see in these questions, you will also learn the concepts. So it's not just solving the question, but you have to also see what type of concepts that you are getting from those particular question. So you have to note those points also. So let's start with question number 1. So see question number 1, the solution of the differential equation. This particular differential equation is given and R family of means you have to write the solution and then you have to analyze the solution. What type of option that you will get? So whether it's an ellipse with different eccentricities, circle with different centers, circle with different radii, and ellipse with different foci. So let's see. So whenever you will encounter any question, first you have to see, let's say if it's a differential equation. So first you have identified that in mathematical physics, it is based on differential equation. Then in differential equation, you have first order, second order. So you have identified it's a first order differential equation. So there are different types of first order. So which type is this? So you can have a variable separable method. So here we will apply it variable separable. So that is how you have during exam condition also what you have to do if you will encounter one particular question. So you have to mentally you should categorize that it's a mathematical physics, then it's a differential equation, then it is first order, then which type you will apply variable separable method. That is how you have to solve the questions. So here you should write it as, let's multiply, we have to separate the variable x and y on different side. So it's a variable separable. Now if you integrate, what you will get? Y plus 1 whole square by 2. And here you will get minus x square by 2 plus some constant c. And then let's multiply both side by 2 and then rearrange. So this will give you x square plus y plus 1 whole square is equal to 2c. And let's take it as r square. Now you know it's an equation of circle. This represents an equation of circle. It's an equation of circle. So what is general equation of circle? What is the general equation of circle that you have to compare? So you know x minus a whole square, y minus b whole square, and let's say radius is r square. So here center is what? Center is AB and radius is R. So if you see this particular equation, what will be its center? Its center is 0 and minus 1. 0 and minus 1 will be the center. So center is fixed here. And what will be radius? Radius R will be given by under root 2c. This R will be 2c and c is any general constant. So c is variable. So it means radius is changing. So it's a circle with different radii. It's a circle with different radii. So note it down. Is it clear? So now we will move on to the next question. Okay. So next question. Now see, in this question, a complex function is given fz and you have to identify the singularity. What type of singularity is there? So it's an exponential function. So what we will do when in this case, we will write the Laurent series. And you know that in a Laurent series, if there are finite number of negative powers of z minus a, then we say that it's a pole of some order n. That is the finite number. How many highest number is possible? And then if it has infinite number of negative power of z minus a, then we say that it has essential singularity at z is equal to a. So that's why we will see the expansion and then we will see whether in Laurent series there are infinite number of terms or finite number of terms. So fz is, I'm writing it as, this is fz exponential z minus 1 into exponential 1 by z minus 1. You will get two terms. Now, you know expansion of exponential. So first we'll give you what? 1 plus z minus 1 plus z minus 1 whole square by factorial 2 plus and so on. This is expansion of e power z minus 1. Then we have to see exponential 1 by 1 minus z minus 1. So 1 plus 1 by z minus 1 plus 1 by z minus 1 whole square factorial 2 plus and so on. Is it clear? So if you multiply these two terms, so one by one you have to multiply. So if you multiply this, you will get infinite number of z power z minus 1. So this here you will get negative power z minus power 1. This is z minus power minus 2. So they are negative power. This is the positive power. So you have to see negative power. So at z is equal to 1, function will be singular. And how many number of terms you will get? You will get, there will be, here you have, if you multiply, you will see it has infinite number of negative powers of z minus 1. Negative powers of z minus 1. Infinite number you are getting. So it means z is equal to 1 is an essential singularity. So z is equal to 1 is an essential singularity. So that's why option B is correct. So at z is equal to 1, there is an essential singularity for this particular function. Clear? So note it down. So in this particular question, you have applied the you have identified the singularity by writing the Laurent expansion. So as I have already told you, in exam condition also, you have to identify that particular question, whether it is from mathematical, EMT or any other topic. So if you have identified that it's a mathematical physics question, then it's a complex variable question. Then you have to see how to write the Laurent series, whether you are getting finite or infinite terms, and then you can solve it. So if you are able to do that, only then you will be able to solve these questions. Yes or no? Chalo. So now next question is, just see, do the same thing. So in this, I have taken only MP. So it's a mathematical physics question. Again, it's a matrix problem. And which concept you have to apply? If you see, so it's like you have Cayley-Hamilton theorem. You have to apply Cayley-Hamilton theorem that every square matrix satisfies its own characteristic equation. So you have to write the characteristic equation and then you should replace the eigenvalue by the matrix. So let's see. So we will use here Cayley-Hamilton theorem. So for first you have to write the characteristic equation. Characteristic equation. How to write the characteristic equation? You have to write determinant A minus lambda I should be 0. I is the identity matrix of 3 cross 3. I is the identity matrix of 3 cross 3 size. So this will be 2 minus lambda. This is minus 1, 0. And then you will get minus 1, 3 minus lambda and 1. And this will give you 0, 1, 0 minus lambda. Clear? So, and this should be 0. So if you expand this, you will get, now see 2 minus lambda. So you have to cross multiply. So this is 3 minus lambda into minus lambda and then minus 1. This will be the first term. Then you have with minus sign, you have minus 1. So what you will get? This is lambda minus 0. Clear? So let's multiply here. What you will get? 2 minus lambda. It's a matter of calculation now. Minus 3 lambda plus lambda square minus 1 minus 1 and this is plus lambda is equal to 0. Plus lambda is equal to 0. Now let's see what you will get. Minus 6 lambda. This is minus 6 lambda plus 2 lambda square minus 2. And then you have plus 3 lambda square. Then minus lambda cube. And then plus lambda is equal to 0. Because it is written in a cube, so I am writing it as, let's write lambda cube only. So if you, let's put it on right side. So what you will get, this is 2 lambda square plus 3 lambda square. So you will get 5 lambda square. Minus 6 lambda plus, so minus 4 lambda. This is minus 4 lambda. And you have minus 2. So this is your characteristic equation. And now from Cayley-Hamilton theorem. Cayley-Hamilton's theorem. Every square matrix satisfies its own characteristic equation. So what you will get, this lambda is replaced by a. So this is a cube 5a square minus 4a. And here I will write in matrix equation, I will write I is the identity matrix of same size 3 cross 3. So you have to identify which one is correct. So I think option A is correct. So A option is correct option. So note it down. Clear? So now we will see next question. So let's see. So if you see this question, it's a based on the Dirac delta function. And there are two variables, x and y. So it's application of Dirac delta function in 2 dimension. So let's see how we'll solve this question. So if you see the question here, I'm taking, let's say this integral is I that you have to solve. So y varies from 1 to e. Here, y varies from 1 to e. Y varies from 1 to e and x varies from 0 to 5. So this e value is less than 5. E lies between 2 to 3. So this y value lies in this range. If you have x, let's say x value is 0 and x value is 0 and x value is 5. So y lies between, let's say this is 1 to e. So y lies between 1 to y is equal to e. So in this range, this y is equal to x. In this range, y is equal to x. So what we will do, we will first see the this x integral we will solve. Let's see how to solve the x integral. So we will take how to write. First we have to see what will be delta x square minus y square. What should be this value? So for that, you know the general result that delta fx is given by summation over delta x minus xi by let's see, by mod fx f dash xi mod f dash xi. So if you use this result, then we can write delta x square minus y square. So let fx is, and what is fx here? Where xi is the solution of fx is equal to 0. So you have, whenever you have to write delta of fx, you have to use this method. So let fx is 0, fx is x square minus y square is equal to 0. So this will give you x is equal to plus minus y. But x is positive here. Since x is positive, so which value of x you have to take? So you have to take only positive value. So I will take x is equal to plus y only. X is equal to plus y only. So there is a one value of xi. So here this xi is x1 only. Here you will get x1 only. So when you are treating x variable, I am taking y as a constant. And in the range 1 to e, y is this value, y and x have same value. So integral I am writing here. Let's see how we will write this value. You should write this particular thing as delta x minus y by fx is, what is f dash x? That is mod 2x. And this value will be, because x is positive, so delta x minus y by 2x. So this you can write. So accordingly, if you solve this integral 1 to e, now you have 0 to 5. This delta x square minus is delta x minus y by 2x I have replaced delta x square minus y square by delta x minus y by 2x, and the function is ln xy. And this is dy here, and then this is dx. And you know the property of delta function, that if you have delta x minus a fx dx, let's take minus infinity to infinity, means in that range x is equal to a lies. So this value will be what? Simply value of the function at a. So similarly, because y lies in this range, so we can write here y is equal to 1 to e. This value you should write, this will be given by ln x is equal to y. So this is ln x is equal to y, ln y square by 2y into dy. Function is ln xy by 2x. So now this you can write as 1 to e. So this will be give you 2 ln y. So this is simply ln y by y dy. Now let how to solve this integral. So let ln y is t. So this will give you 1 by y dy is new variable dt. And when y is equal to 1, this will give you t is equal to 0. And when y is equal to e, this will give you t is equal to 1. So accordingly, this limit will be t is equal to 0 to t is equal to 1. This is t dt, and you will get t square by 2, 0 to 1. So this will give you 1 by. So in this case, this particular integral value is 1 by 2. So it's application of Dirac delta function in 2D. Clear? So in today's session, I have discussed part B. In tomorrow's session, I will discuss the part C. Clear? So note it down. Chalo fir. Okay. Thank you. Thank you everyone. Thanks for watching.